Hello students, let us solve a problem from NEET UG Paper 221. Here is the problem. The problem states that a nucleus with mass number 240 breaks into two fragments of each of mass number 120. The binding energy per nucleon of unfragmented nuclei is 7.6 MeV, while that of fragments is 8.5 MeV. The total gain in the binding energy in the process you have to calculate. So look, the reaction given over here can be represented by this. So X is the parent nucleus which has mass number 240, and Y and Z, these are the product or the daughter nuclei, and each of them has the same mass number 120. And Q is the energy released in this reaction. This is typically a fission reaction, and there will be release in energy because there is gain in binding energy, and this energy Q is actually the measure of gain in binding energy. So we have to find out or calculate the gain, total gain in binding energy in this fission reaction. So what is binding energy per nucleon? It is binding energy, total binding energy divided by mass number. Now, how to calculate gain in binding energy? It is very simple. You have to subtract the binding energy, total binding energy of the parent nuclei from the total binding energy of the daughter nuclei. Now you have to find out what is total binding energy of the parent nuclei. That is, see, the binding energy per nucleon is given, that is 7.6 MeV. Then you have to multiply 240 to get the total binding energy, because this is binding energy per nucleon. So we see the binding energy per nucleon is 7.6. So the total binding energy of the parent nucleus is 1824 MeV. And similarly, you have to find out the binding energy, total binding energy of the daughter nuclei, and that can be calculated by this 2 into 120 into 8.5. 8.5 is the binding energy per nucleon. So there are 120 mass number. So this is, and there are two daughter nuclei. So 2 into this. So that gives rise to 2040 MeV. Now if you take the difference, then you will get the total gain in the binding energy during this fission reaction or during this process. So that turns out to be 216 MeV. So the total gain in binding energy in this process will be 216 MeV, and hence fourth option will be the correct answer for this problem.